All right, physicists, we are here for investigation 5B, looking at the analysis on part 2. This is again where we had the rolling car. We measured its initial speed, or rather its initial gate time for A, its gate time for B. Now I'm going to walk you through finding the velocities, the change in velocity, and the acceleration so that we can come up with our friction force. Again, we'll just walk through one. I'll leave the others for you. First job, we need to know our velocities. As you've done lots of times before, distance over time. And remember the length of the gate, of course, or sorry, the flag is 0.01 meters. So my first one here is 0.0072 seconds. Grab the calculator, 0.01 divided by 0.0072 looks like 1.39 meters per second. There's our initial speed. Okay, for the second one, I've got 0.0078. So I'm doing the same calculation, velocity, distance over time, 0.01 meters of photo gate of flag, and 0.0078 seconds. So 0.01 divided by 0.0078, and we're looking at 1.28. Hey, this isn't just a bunch of numbers. Look at this. The car was going 1.39 meters per second. It slowed down just a smidge to 1.28. How much change was it? Well, the change in velocity, that's the end or the final velocity minus the initial. So the change in velocity, that's our ending velocity, 1.28 meters per second, minus our starting velocity, 1.39 meters per second. I could get out my calculator, or I could probably handle this one in my head. That looks a lot like negative 0.11 meters per second. Why negative? Well, of course, the car's slowing down. So I've got a change in velocity of negative 0.11 meters per second. Last step, let's find out how much acceleration there is. Got the equation here in case you need a reminder. Acceleration is change in velocity over the time it takes. So we know our change in velocity, negative 0.11. We know the time it takes, 0.2965 seconds. Grabbing the handy dandy calculator, 0.11 divided by 0.2965, and I'm seeing 0.37. Again, a negative because we're slowing down, 0.371 meters per second per second. Hey, it's slowing down. Here's how much it's slowing down per second. Our good friend Newton's second law has come back to help us. We want to know the friction force. That's what's causing the slowdown. We know that force is mass times acceleration. In this case, it's going to be the friction force. Usually it's just the net force, but that's all that's acting. So again, I go back here to my first run. The data, we measured a 0.056 kilogram car. We're multiplying by our acceleration of negative 0.371 meters per second squared. And again, the calculator comes out 0.056 times 0.371 shows up at 0.02. Gosh, that's tiny. 0.02. I'm keeping the negative sign because that just tells us if the velocity is this way, hey, the friction force is the other way. Makes some sense, it slowed down. Gosh, that's a really small friction force. I don't know if you remember the first one, but the first friction force we did with the sliding was almost 5 times bigger. All right, so that's a sample. Again, we measured the photo gate times. We used them to find the speeds. We found out the change in speed. That got us the acceleration. And then finally, we made it to the friction force. That was a lot. But the neat thing is it just puts together the tools we've been using together this spring. All right, your job is to walk through the balance of the analysis, and let's see how this friction force changes as we add more mass to the car.